Hello everyone, in this video I will be discussing to you Degenerate Conics. Degenerate conics can be two intersecting lines, a line, or a point. Now allow me to access Desmos.com on the web and let me show to you what degenerate conics are. So this is Desmos.com. You may use this website for graphing purposes. As you can see, I already encoded the equations here on the left. I will only show to you what happens to a circle when we decrease its radius. Okay, so in this case, I already set the center of the circles to 2 and -1. So all these equations of circles have the same center. Okay, so for example, the first circle here, this is a circle of radius 5 whose center is at 2 and -1. So 2 and -1 is somewhere 2 and then -1. So this is the center of the circle. Okay. Then for the second equation, I reduce the equation from 5 as a radius, it becomes now the square root of 10 as a radius. 25 is r squared, as you know. 10 is also r squared. So to get the radius, we take the square root. Square root of 25 is 5, square root of 10, and it's 3 point something. Okay, so as you can see, the circle is getting smaller. And then if we continue until equation 3, becomes smaller than the green circle until this one, and then equation number 5. So you can see it's almost a point. But then actually, if you will try to zoom it in, that is still a circle. Okay, there's still a circle there. And then if we continue to decrease the value of r squared, then it will continue also to decrease the value of r. So we have there, actually you cannot almost see any other changes, but there is still a circle, a very tiny circle. Okay, now what happens to the circle if we set the value of r squared equal to 0? Of course, it will follow that r will be 0 as well, because the square root of 0 is also 0. Okay, let me show it to you. If I click that one, you cannot actually see any other circle. If you will zoom it in, something is here, but it's not actually a circle. Okay, so this is the limitation of Desmos.com. It did not graph a circle, instead it graphed something, this dash line. Okay, but actually this is an indicator that the graph is somewhere here, and it only graphed the point. Okay, what point? Only the center. So this graph, or the graph of this equation, is actually a graph of a point, and that point is the center of the circle. It means that if you want to be specific, I'll just add here 2 and -1. This is the graph of that equation. Okay, so this place. Here, this is in a format of an equation of a circle, but since this is not anymore a circle, the Desmos.com only reacted a dashed line, when supposedly this is a single point. Okay, so again, let me repeat, this equation of the circle is not anymore a circle. Okay, it will not give you a graph of a circle, instead it will give you a graph of a point. For what reason? It's because r squared is now set to 0, and we call it a degenerate conic. So a circle degenerates when the value of r squared is equal to 0, because it will lead to a value of r equal to 0 as well. Okay? Now, if we continue to decrease the value of r squared to a negative number like this one, now if it is a negative number, remember that to get the value of r, then we have to consider the square root of r squared, okay, in order for us to get the value of r. But then this is a negative number, and when we take the square root, it will lead us to an imaginary number. When we say imaginary number, that is not a real number, so it does not exist, or it is undefined. If we will do that, let me illustrate it to you. I'll just remove this and also this one, so nothing is on the graph, nothing is on the rectangular coordinate system. If I will click this one, you cannot even see a point, you cannot even see a dash line on the Desmos app. It's because this cannot be graphed in a rectangular coordinate system. Okay, we can graph this one in a special plane called the complex plane, but since we are focused on rectangular coordinate system, we call this as an equation of a degenerate conic. Okay, also, so aside from this one, this is also a degenerate conic. So a circle degenerates when r squared is equal to 0 or when its value is negative, because when we do the square root of a negative number, it becomes imaginary, so it cannot be graphed in a rectangular coordinate system. Or in short, this is not or this is a circle, this is an undefined circle. Let's make it simple. This is an undefined circle. Or in short, this circle or the circle does not exist at this time. Okay? Let's talk about the parabola this time. Okay, so how about the parabola? I have prepared this equation of the parabola here, opening upwards, and I have set the focal distance to 0, k is 0, and also h is 0. So the vertex is actually at the origin. You can change it later. Okay. So if I'll open the graph, I'll show this to you. Actually, as you can see, this is a line, right? This is a vertical line. It is exactly the y-axis. What happened? If I will move the value of k, then nothing happens. If I'll move the value of h, then it transfers from one place to another. Okay, because this h is the value of the x coordinate, correct? So h is always the x coordinate of the vertex. So let me explain this to you. Why is this a line? When in fact we have this equation of the parabola. It's because the parabola degenerated. For what reason? Or when do we say that the parabola will degenerate? It happens when the value of p is equal to 0. That means the focal distance is 0. If you can still remember, the focal distance is the distance from the vertex to a focus of the parabola. Now, if the distance between them is 0, then that means the focus is the same with the vertex this time. So if they are overlapping, then we cannot have a parabola. Instead, we have this straight line. Okay, it's a vertical line if the parabola is opening upward or downwards. It will be a horizontal line if the parabola is opening right or opening left. If I will get another value of p, for example, aside from 0, oh, you see there is a parabola this time. It's getting wider and wider when the value of p increases. It becomes narrow when the value of p decreases. Okay, that's how it works. And it becomes a straight line when the value of p is equal to 0. So remember, when the focal distance is 0, then that's the time that the parabola becomes a straight line, or when that's the time that the parabola becomes a degenerate conic. Of course, if there's a parabola there and then it moves upwards and downwards if I touch the value of k, because k is the y coordinate. Okay, it moves sideways if I'll change the value of h, because h is the value of the x coordinate of the vertex. Okay, so the idea is the parabola degenerates when the value of p becomes 0. And then another thing, the opening is getting wide and wide when p increases, while it becomes narrow when p decreases until it becomes a straight line. And then I have to emphasize that the straight line here, okay, that the straight line is just the how do you call this? The axis of symmetry. Let's say, for example, it's set to h to something like 3. Okay. So when h is 3, then of course the equation is x minus 3. And let me change it na lang. if this is 3, 3, and then let's have another value of k, let's have 1, negative 1, let's have 1 here, so y minus 1. And then our p is, if p is 0, what happens to the parabola? If p is 0, then 4 times 0 is 0, so 0 times y minus 1, it becomes 0 exactly. So x minus 2 quantity squared equals 0 will be left, right? So let me add some equation. So that becomes x minus 2 quantity squared equals 0. That's the graph of x minus 2 quantity squared equals 0. Okay, so when p is 0, this equation becomes this equation because p is 0, 4 times 0 is 0, 0 times y minus 1 is also 0. So basically the right side becomes 0. It's just this one. Okay, and when you take the square roots on both sides, okay, when you take the square roots on both sides, square root of this one is just x minus 2, and then the square root of 0 is just 0. So that's, again guys, that's the axis of symmetry. So x minus 2 equals 0 is the axis of symmetry of this parabola. In short, when the parabola degenerates, it disappears and the graph becomes the axis of symmetry. Okay, so it turned out that when the parabola degenerates, what's left on the graph will be the axis of symmetry itself. Notice that it passes through 2 of our x-axis. And of course, if you will transform this equation, this is just the same with x equals 2. So when we say x equals 2 based on the review in hyperbola, x equals 2 is a vertical line which passes through 2 of the x-axis, and that is what's happening here. Okay, so we already have two degenerate conics. One is a circle. A circle degenerates when the radius is equal to 0 or when r squared is a negative number. Now for parabola, it degenerates when the value of p, or the focal distance, is equal to 0. And always take note that the parabola degenerates and becoming just the axis of symmetry. Let's proceed to ellipse now. And I have prepared the equation here. This is the standard equation of the ellipse, and then all the values here of a, b, h, and k are changeable. So h and k can be any number. This time I set the center to 2 and 2, right? So h and k are 2 and 2. A and b are of different values, but it can be changed later. Showing the graph is this one. This is our ellipse. The center is at 2 and 2. So there's 2 and 2. Here, 2, 2. If I'll change, of course, then when h changes, then the ellipse will be shifting right and left. Because remember, h is the x-coordinate of the center. Now, if I'll change k, while removing k, it is shifting up and down because k is the y-coordinate of our center. Let's just put it in a whole number. Let's have it as 2 and 4. Okay, so that's 4, 2. The center now of the ellipse is at 4, 2. Then, if you have this value of a equal to 0, you cannot actually see the ellipse. Okay, you cannot see anything. It's because this becomes undefined. This part here of the equation becomes undefined. And when the term is undefined, then it will make the whole equation undefined. So there's no ellipse at all. Same with when b is 0. When b is 0, then that means there's no graph for the ellipse because this portion here of the equation becomes undefined. So a and b must be something else aside from 0. It cannot be 0 because it will make the equation undefined. So if a and b are not 0, then it becomes an ellipse. Okay, so as I said, circle is just a special kind of ellipse. Notice that if I'll move the value of b going to the value of a, this is approaching 6.77. I'm trying to make them equal. I don't know if I can make it. But if it becomes exactly 6.77 also, oops, no, I cannot do it. I'll just make it a whole number, 7. If you have 7 and 7, then it becomes a circle. So the ellipse becomes a circle when A and B are equal. Okay, so when A and B are equal, then the ellipse becomes a circle. That's the reason why circle is considered an ellipse of special case. It's a special case because it will only happen when A and B are equal. Now let's talk about the degenerate conic. When can we see a degenerate conic of the ellipse? It becomes a degenerate conic when this value here at the right side is 0. Same as the circle actually. This is 1 in the standard form. I can change it to something else like 12. It's okay. There's still the graph of the circle. There's still a graph of the ellipse if I will change the value of A. Okay. There's still ellipse. Now, if I will make it smaller and smaller, like it's equal to 0.5, then the ellipse also is very small. If I'll change it to something smaller than 0.5, like 0.1, then the ellipse is getting smaller, but there exists an ellipse still. If I'll change it to 0.01, what happened? 0.01. Okay, so there's still an ellipse, as I said. So as long as there's a value here aside from 0, or there's a positive value here on the right side, then ellipse will still exist. It will not exist, guys, if the value is equal to 0 or a negative number, just like the circle. So if you want, this will be the same situation as a circle. If I will make it like 0.01, 0.001, then it's becoming smaller. 0.001, that one. Okay, it's almost a point, but actually that is still an ellipse. That is still an ellipse. Yeah, this time a very small ellipse. And then until I'll make it, I don't know if I can make it to 0 directly this time. Let's have it more. Okay, it's really small this time. This is the ellipse. There exists an ellipse. And if I will change A and B, it will still affect. Notice that if I will change B, it will change the width of our ellipse. It will change the width. Why the width? Because look at B. Look at the value. Look at the variable B here of the equation. B is the denominator of the x variable. X is the horizontal axis. That means it will affect the horizontal width of our ellipse. So that's why every time I'll change B, then the height will not change. It will only change the width. The B value will change the width of our ellipse. Of course, there will be times that B is here and A is here. So that's another scenario. It will exchange the situation. Like if A is here, then A will change the width. In this case, A is under the y variable, which is vertical. That means it will change the height of our ellipse every time I'll change the value of A. Okay? Now, if I'll set it to 0, what happens to our ellipse if it's equal to 0? Okay, look at that. There's this orange line, orange dash line, just like the circle. So it's not anymore an ellipse, but a dash line, which indicates the graph is somewhere here. And I tell you that the graph of this is just the center of our ellipse. That's H and K. Okay, so there's the graph in there. Notice that it's really a point, and that point is actually the center of the ellipse, H and K. If that is 0, of course, if this is 0, but if it is a negative number, I tell you it will not give you anything. So again, remember, if it is 0, it will give you a dash line indicating that is the position, or that is the place where the graph is located. Now, if it is a negative number, it will not show you anything, not even a dash line. Okay, so in this case, that means the graph of the ellipse does not exist. So this situation is the same as the circle. Circle and ellipse, when degenerated, it will become a point. Okay, when the right side becomes negative, then there's no graph at all. That means undefined. If parabola, when degenerated, it becomes a line, then how about hyperbola? So we have this hyperbola here on the screen. So I already showed it. This is the hyperbola The transverse axis is actually horizontal. Horizontal because look at a squared. A squared is under, or it is the denominator of the x variable. So it doesn't matter if it is longer than b or shorter than b. Shorter than b, it is still the hyperbola, and the transverse axis is horizontal. Now, guys, if it is 0, then there's no graph at all. The same as the ellipse. And it is if it is equal or a and b are equal, then what happens? In ellipse, if a and b are equal, then the ellipse becomes a circle. But here in hyperbola, when a and b are equal, it is still the same hyperbola. Okay, it is still a hyperbola. What happens is just the auxiliary rectangle becomes an auxiliary square. So this is the special case. The special case here, a and b will be equal, and then there is a special case on the auxiliary rectangle, but not in the hyperbola. Okay, let me repeat. Let me repeat the difference. Okay, in ellipse, if a and b are equal, the ellipse becomes a circle. Okay, here in hyperbola, if a and b are equal, nothing will be special in the hyperbola. There's special thing happened in the auxiliary rectangle because the auxiliary rectangle becomes a square this time if a and b are equal. Okay, so that's it. That's it. When do we have a degenerate conic for hyperbola? It's actually the same situation in the circle. That is when this constant term here of the equation becomes 0. If it is 0, people, it becomes two intersecting lines. Okay? So the hyperbola becomes two intersecting lines when this constant term here becomes 0. Well, honestly, you can change these values here into something else, like 12 that is still hyperbola, like 5 that is still sorry, should erase that. You have 5 that is still hyperbola, if you have 7 that is still hyperbola. But if it is 0, it is not a hyperbola anymore, it is two intersecting lines. And I tell you people, these two intersecting lines are just the asymptotes of the hyperbola. So we have this idea, okay, if parabola degenerates, it becomes the axis of symmetry. Here in hyperbola, if it degenerates, it becomes the axis. No, not the axis, it becomes the asymptotes of the hyperbola. Okay, so to summarize everything, circle and ellipse, when they degenerate, they become the centers. When we have parabolas, when they degenerate, they become the axis of symmetry. Okay, if we have this hyperbola, when it degenerates, it becomes the asymptotes. That's it. Okay, and remember, in ellipse, if this value is negative, okay, if this value is negative, the whole graph disappears. Not even a point, not even the dashed line a while ago showed in the Desmos application. In hyperbola, it's different. It's different here because if it is negative, there exists another hyperbola. Okay, what happened? It only changed the position of the transverse axis. Remember, if this is 1 or positive, the transverse axis is horizontal, right? It's horizontal. Now, if I will change it to a negative number, negative 1, for example, then what happened to the hyperbola? It becomes a hyperbola opening upwards and downwards. A while ago, it was the hyperbola opening right and left. Now we have this hyperbola opening up and down. So the transverse axis from the horizontal position, it becomes the vertical position this time if the value of the constant at the right becomes negative. So unlike ellipse, if this is negative, ellipse will disappear. That means there's no conic section at all. Okay, here in hyperbola, if this is negative, okay, if this is negative, it will change the position of the transverse axis, but there exists a hyperbola. So there's only one situation. There's only one situation that will make the hyperbola a degenerate conic, and that is when this constant here at the right becomes 0. In ellipse and circle, there are two situations. The two situations are when this constant term at the right, here look at the ellipse, when this constant term at the right is 0, it is a degenerate conic called a point, or when this number is negative, there's no graph at all, it is still a degenerate conic. Okay, so that's it for degenerate conics. Goodbye.